Hi, welcome. I just want to go through this PowerPoint really very fast to explain the reactivity of metals. This is our next topic after looking through endothermic and exothermic reactions. You find this topic to be more simpler because you already have knowledge from exothermic and endothermic reactions. So in this section, when we are looking at discussing about the reactivity of metals, we're going to observe how metals react with different things. And then from their reactions, we can be able to classify them from the most reactive to the least reactive. So to put this into context here, we're going to look at how metals react with three specific things. One is how they react with oxygen. Two, it is how they react with water. And three, it is how they react with dilute acids. So from those three, we can be able to predict or come up with a ranking of metals in terms of reactivity. So the first slide here, we're looking at the reaction of metals with oxygen. We had already talked about this, that metals, when metals react, the reaction of metals here, I'm going to annotate on the slide. When metals react with oxygen, we get what we call metal oxide. This one here, we get a metal oxide. This is what we get when metals react with oxygen. Now, the example on the slide here is magnesium. So I can write the symbol equation for the reaction that is happening. Remember, you should be able to write both symbol equations and word equations for the reactions. So this is magnesium reacting with oxygen, then we get magnesium oxide. This is the formula for magnesium oxide, MgO. Then you need to include the state symbols. This is a solid, magnesium is a solid, and then oxygen is a gas. Check that it's balanced. This is one mole of magnesium here, 1 mole of magnesium, 2 of oxygen on this side, so we need to put 2 here. But because we have placed 2 here, this means that we also need to balance magnesium on the right hand side. So remember, the number of atoms on the left side and the right hand side must always be equal when you're writing chemical equations, and the state symbols must be there. So metals react with oxygen to make metal oxides. Again, in terms of reactivity, the way different metals react with oxygen is different. Some metals react very violently with oxygen, and some reactions with oxygen are very fast. For example, we looked at rusting, which is the reaction of iron and oxygen. So this is an example of a reaction which is very slow when iron reacts with oxygen in the presence of water to make rust. Iron reacting with oxygen, and then it forms iron 3 oxide, okay, in the presence of water. So by observing how metals react with oxygen, then we can be able to rank them in terms of reactivity. Then the next slide, this is the periodic table, which is showing you the sections of the metals. Again, just to review on this section, we said the periodic table is divided into two big categories, that is into metals and non-metals. In between here, there is a section for metalloids, which are those elements that exhibit properties of both metals and non-metals. I will be able to put another periodic table which shows that one clear. But we can see here, the metals are on the left side, this side of the periodic table. That is where you find most of the metals. And then the non-metals are towards the right-hand side of the periodic table. So you can see the majority of the metals occupy the left hand side of the periodic table, and the central section here, these are all metals here. We call them transition metals. All right. This the metal section. This is the non-metal section. So since we are talking about metals, so we concentrate on the metal section. And the reason why these metals have been highlighted as yellow here, as an example, this is among the group of metals that are very reactive, mostly group 1 and group 2. Now, group 1 here is the most reactive group of the periodic table. And this group, we call it alkali metals. These are group 1 metals. We call them alkali metals. Moving on to the next slide. So we are now going to look at how different group 1 metals react with oxygen. So if you take pieces of lithium, we have, for group 1, we have lithium as the first element. We have sodium, then followed by potassium. Then we have francium, and then we have cesium. We don't really put emphasis on the last two elements because they are very extremely reactive, and they are radioactive, so they have a very short half-life. But we can be able to predict the reactions of group 1 metals by just looking at the first three. So when you have pieces of lithium, sodium, and potassium, if you put them in a container, when you remove them from the container where they are stored, usually they are very shiny. But within seconds, when you expose them, they become very dull because they react with oxygen very, very fast. Now, because of their reactivity with oxygen, usually group 1 metals, we store them under oil. So you may find that we have this in the lab, but these metals, they must be stored under oil because of the reactivity. They can easily react with oxygen or moisture, and they can explode. So that tells you about the reactivity of group 1 metals. They are super reactive. Now, in terms of how the trend is in this group, is that as you go down the group, it becomes more and more reactive. So lithium is the most reactive group, the most reactive metal in the group, not the most reactive, sorry, the least reactive in the group, then followed by sodium, then followed by potassium, then as you go down. So you can see potassium here is the most reactive, and then lithium is the least reactive. This reaction becomes very evident again when we see how they react with water. So the general equation is a metal plus oxygen is equals to the metal oxide. Different metals have different reactivities with oxygen. Some metals react very vigorously, or they are explosive when they react with oxygen, and some metals, they have a very slow reaction with oxygen. The group 1 metals, we have said that as you go down the group, the reactivity of these metals increase. They become more and more reactive. Now, it's also important to note that this group of metals here are unique on their own, because this is the only group of metals which are actually very soft. Typical metals are not very soft, but group 1 metals are very soft, that you can actually be able to cut these metals with a knife. So that is very, very unique of this metal. So the softness is also attributed to their reactivity. They are very, very reactive. The next slide shows the reaction of group 1 metals with water. This is a demonstration which I've already described in class. If you missed this demonstration, I've included the link is down here. Please open this link where you can access the video clip for the demonstration for the reaction between group 1 metals and water. Those of us who were in class, you remember how these three metals react with water. Lithium here being the least reactive, and this is potassium, which is super explosive with water. It produces flames if you use a bigger piece of potassium. So when we are doing this demonstration in the school lab, we try to use very small pieces of these metals. So hopefully once we are back in school, we'll be able to do some of the demonstrations. But this one here is a little bit dangerous. So this is lithium, this is sodium, and then this is potassium. In terms of reactivity, we have already said that the reactivity increases as you go down the group. So lithium is the least reactive from this group, and then potassium will be the most reactive on this section. And then both or all the three metals, when they react with water, you form two products. We get the metal hydroxide plus hydrogen gas. So if it's lithium, lithium reacts with water, and when lithium reacts with water, we get what we call lithium hydroxide plus hydrogen gas. Then please follow my instructions from the previous slide in terms of including the state symbols and also balancing. I'm just not going to do this because the space here is very small. And then if it's sodium, same thing as well. So you have sodium reacting with water, and when sodium reacts with water, you form sodium hydroxide, NaOH plus hydrogen as well. So the gas produced here is hydrogen, and therefore you're going to one of the observations when this reaction takes place is effervescence or some fizzing sound as a confirmatory or a confirmation that a gas is being produced, and the gas produced here is hydrogen gas. Remember, as we said in class, that the confirmatory test for hydrogen gas, when you want to confirm hydrogen gas in the lab, we use what you call a lighted splint or a burning splint, and it should be able to produce a pop sound. A lighted or burning splint. Then it produces a pop sound. If there's no pop sound, then that gas is not hydrogen. Then the next page, potassium is the most reactive and it's lower down the group. I've already talked about this. So as you go down the group, the reactivity of group 1 metals increase. And the general equation of reaction is that metals react with water, we form metal hydroxide plus hydrogen gas. With metal hydroxides, these are alkaline solutions. So if you test the pH of the solution that is left behind when these metals react with water, you find that the pH is alkaline. So those who don't know alkaline pH, you check, we have a pH scale is from 0 to 14. This is the pH scale. Then 7 is the neutral position, 14. This side is for bases, and this side is for acids. A pH which is below 7 is acidic, and a pH that is beyond 7 is basic, and 7 is neutral. So if you test the pH of these solutions that are left behind here, you find that they are mostly alkaline. So the pH will be somewhere here. Actually, very strong alkaline solutions. So the pH will be somewhere around here, 11, 12, 11, 12, 13. Okay, that is where you find the pH. For acids, when the pH is very, very small, it means that the acid is very, very strong. So acids whose pH is like 1, 2, these acids are very strong acids. So this is where you find the pH for acids like hydrochloric acid, for acids like sulfuric acid, H2SO4. This is sulfuric acid. Acids like nitric acid, so pH scale from 1, 2, 3. This is where you find very, very strong acids. That is the pH scale. Around the pH scale of 4, 5, 6, 7 here, not 7, but 4, 5 here, up to 6 point something here, we find those substances that are slightly acidic. Now, slightly acidic, for example, something like carbonic acid, the one you find in carbonated drinks, the ones you take, like cola. Okay, so that is just additional explanation on that. So the reaction of metals with water, you get metal hydroxide plus hydrogen. Now, on this slide, it brings also another aspect that not all metals can react with water. Actually, for some metals, when you put them in water, you can come and then you don't find any reaction at all. Why? Because they are not reactive enough to react with water. So for some metals, the reaction is very slow when it reacts with just cold water, but for some metals, the reaction is actually very fast if you react them with steam. Now, steam is water vapor. This is water vapor. So if you, instead of just putting them in cold water, you react them with steam. These reactions, these metals, they react very vigorously when you put them in water vapor instead, because the reaction probably needs some heat. So an example, a very good example here is magnesium. Magnesium reacts very slowly with water, cold water, but when you react it with steam, the reaction is very, very vigorous, and we get what we call magnesium oxide plus hydrogen gas. Now, take note of the difference here of the product we get. So those metals which react with steam, instead of getting a metal hydroxide, you get a metal oxide plus hydrogen gas. Okay, so that is the difference between this. So some metals are super reactive, that they can actually just react with cold water. The best example for this is group 1 metals. You don't need to do anything, you just drop them in water and the reaction starts explosive. Some metals have a slow reaction with just cold water, and I've given a good example for this to be magnesium. When you put it in cold water, yes, there is a reaction. Yes, you get some bubbles of hydrogen gas, but the reaction is super slow. Not very slow, but slow. But if you take the same piece of magnesium and then you now react it with steam instead, like in this example demonstration here, you get the magnesium ribbon and then you have steam produced here reacting with this magnesium. Uh, Very vigorous reaction, and instead of getting a metal hydroxide, you get a metal oxide plus hydrogen gas. This is a metal oxide plus hydrogen gas. So you can do this for other examples as well. For other metals, there's no reaction. If, for example, metals like gold is super unreactive. So if you drop it in water, there will be no reaction. Okay, I'll give a summary at the end of how metals react. Then, so this is the brief summary of what we have talked on reactivity of metals with oxygen and water. Group 1 metals, they react vigorously with water. The metals near the bottom of group 1, they react more vigorously than those at the top. Remember the sequence or the order of group 1 metals. We have said the first one is lithium, followed by sodium, followed by potassium, followed by francium, followed by cesium. And reactivity here at the bottom here, this one here is the most reactive. This is the most reactive, and this is the least reactive. Okay, some metals react with hot water or steam, but not cold water. I've given you an example of metals like magnesium, calcium, aluminium as well. They react with cold water, with steam, and very slow reaction or no reaction with cold water. Now, a metal that I need to discuss about, and I think it will come in the next slides, is aluminium. Aluminium is among the top metals in the reactivity series. We are going to look at the series. Aluminium is among the most reactive metals, but the reaction of aluminium in most cases is going to be super slow or no reaction in most cases, because aluminium reacts with oxygen very, very fast. And when aluminium reacts with oxygen, it forms a coating, which is an oxide layer of aluminium oxide. Now, this coating prevents aluminium from further reactions. So, for example, if you need to react it with oxygen or with water, you may have to scratch the surface of aluminium so that it can be able to react. So this is one of the reasons why aluminium may be less reactive, may look like it's less reactive in most cases, because it forms a coating of aluminium oxide. This is an oxide layer that prevents it from further reactions. And finally, the reaction of metals with oxygen, so with dilute acids. So we have looked at the reaction of metals with oxygen, the reaction of metals with water, and the last one is the reaction of metals with acids, dilute acids. We don't work with concentrated acids mostly. Now, when metals react with acids, I think we wrote the general equation in our previous discussions that metals react with acids, and a metal reacting with an acid, we get two things. The product is you get a salt plus hydrogen gas. This is what you get when metals react with dilute acids. We have covered magnesium before, that is why you see it appears here. So magnesium is reacting with hydrochloric acid. Remember, as we said, the name of the salt comes from the metal that is being used and the type of acid you're using. So quick reminder, if the acid is hydrochloric acid, then the salt ends with chloride. If the acid is sulfuric acid, then it ends with sulfate. If the acid is nitric acid, then it ends with nitrate. So that is all you need to remember. So magnesium, then the acid here is hydrochloric acid, then we get magnesium chloride. That is the salt. So this is our salt here, then plus hydrogen gas. So metals react with dilute acids to form salt plus hydrogen gas. How these metals react with acids is different. Some metals, they react very vigorously with these acids, and some metals don't. Now, let's use our first group which we discussed about, group 1 metals, which are the alkali metals. Again, just a reminder, group 1 metals, lithium, sodium, potassium, cesium, francium. So those group of metals, they're super reactive that actually we don't even try in terms of their reactivity with acids. Now what we do is in the lab, we demonstrate reactions with the metals like with magnesium. So we have those ones which are super reactive with acids, and then we have those ones which the reaction with dilute acids is safe for demonstrations in the lab for metals like magnesium or calcium we can be able to demonstrate that in the lab. Then we have some metals which, when you react them with dilute acids, there's no reaction. For example, copper. Copper is one metal which, when you react with a dilute acid, no reaction. Silver, you react them with dilute acid, no reaction. You react gold with the dilute acid, no reaction. Platinum, you react with dilute acid, no reaction, because they're very, very unreactive. So three groups of reactivity basically: those ones which are very reactive, those ones which have medium kind of reaction, and those ones which are unreactive. So group 1 metals are super explosive when they react with dilute acids. But when we come to some of the metals which are in between there, like magnesium and calcium, they have moderate reaction with dilute acids, so safe for most reactions in the lab. And then we have those ones which there is no reaction. That is copper, gold, platinum, silver, and those group of metals. They don't have any reaction with dilute acids. So to summarize this, when a metal reacts with dilute acids, the product is salt plus hydrogen gas. Please remember this, and you can be asked to do the different. You can be asked to do word equations or to do symbol equations. Either way, this is all through practice. You need to practice and write more examples. And now it's easier to be able to counter check and see whether your equation is correct. So if I give you any metal, for example, you check zinc. Once we at the end, you'll be able to determine if the metal can react with dilute acids by using the reactivity series. So for example, if I take zinc, I react with an acid like hydrochloric acid, then I should be able to get the salt. So the salt is zinc chloride. So zinc chloride, the formula is ZnCl2. Okay, then plus hydrogen gas. Then I'll balance this reaction. If you take any other example, which other example we can do? Which example can I do? Let me do calcium plus nitric acid. Okay, the state symbol here is AQ. This is AQ. These are metals, so they are solid. This is AQ. This is gas. Disclaimer that most of these equations are not balanced, so you can balance when you are going through these slides. So calcium plus nitric acid, we get calcium nitrate. Calcium nitrate is written like this because nitrate is valence 1, calcium is valence 2. We write it like this. Then plus hydrogen gas. Okay, so with more practice, you'll be able to know how to, this is AQ, you'll be able to know how to write symbol equations. We'll continue doing more practice. This one goes all the way to the end of grade 11 equations, but the earlier you start practicing, the better, and the more you become an expert in this. And you find chemistry to be very easy as you progress up when you start understanding this.